Alright, good morning students. Welcome to day 6 of learning R. So today we will be learning about models and formula and how you can use different models and different formulas in R. So चलो start करते हैं. So before start करने से पहले let's annotate what we are going to do today is we will learn about models and formulas. How you will use models and formulas in R. So let's define a variable data set and we are using iris dataset. So iris dataset, what do you mean by iris dataset? It means basically iris dataset is already predefined in the environment of R, which contains all the information about the sepal length, petal length of a flower. Okay, now let's try to see what all is there in it. So we have defined this dataset iris, and then if you want to get the idea, let's try to run this. You will get all the details. Alright, data set you will run. So there are 150 entries in this data set, and the columns are your sepal length, sepal width, petal width, and the species of the flower. So there are 3 species, I think: Sentosa, vesicular, and virginica. Okay, now if let's suppose you want to see the starting few entries. पहले मैंने बताया कि starting के few entries अगर आपको check करनी है तो head, you put the name of the variable in which you have defined your iris dataset. So head dataset, then you run it, and then you are getting first 6 rows of this dataset. Same wise, if you want to get the details of the last 6 rows, then there is another function that is tail. Again, you have to put the name of the dataset, and then you try to run it. Then you will get the last 6 rows of the dataset. Alright, what else can you can also get the row number and also the column number of the dataset that we are using. Let's define and call also, and then dataset. So you're getting number of datasets, the number of rows in your dataset is 150 and the number of columns is 5. 1, 2, 3, 4, 5. Alright. So this is basically how you get the details about the dataset, or using different functions that are used in your R. Alright, so now let's dive into your models. Sorry. Let's define a linear model. So let's define a function first. Petals.lm. lm is used for linear function or linear model, and you are putting here in this as lm formula. So these are the basically arguments that needs to be put into this model. So formula equals petal dot length, the name of the column that you want to use, petal dot length. You have to use the same thing, whichever you are with, the names should be same, spelling should be the same, otherwise it will throw some error. So I'm just copying pasting it, petal dot length, and then this you have to use this function. This function is known as tilde function, which basically what is a tilde operator, or tilde not the function, it is a tilde operator. So what it does is it basically, this variable is defined as your response variable, and the variable coming after this is considered as predictor variable. So what we are using as a predictor variable, we are using it petal or petal width. So again, I'm just copy pasting from here to avoid any spelling mistakes. So petal width, and then data is equal to data set. Alright, Now if you try to run this, let's see what happens. So there is no error in this. Alright, now let's try to print this petals.lm. So you are getting the basic statistical data about from this linear formula. The formula that you call is, you have given this thing, and then the coefficients is intercept is 1.084 and the petal width is 2.230. So basically, what is a linear model formula? Linear model formula is basically try to fit in the data in your existing data. I mean, it's like when you have two variables x and y, and then you draw a graph, and then if you calculate the regression of that graph, so it should be close to, as it should be as close to, or you calculate the r square value, it should be as close to 1 as possible to get the maximum maximum similarity. So this is what this formula is doing. So it is calculating the linear model for name of the variable is petals.lm, so it is calculating the linear model for based on this petal length and the petal width. So basically it is if this is considered, this variable is considered as response variable, and this variable is considered as your predictor variable. So based on this petal width will be calculated, and the intercept is 1.084. Alright, now if you have to see the summary of this, what this function has done, summary is another function which can be used for your getting the details of whatever the function, whatever the details are run during this formula. So object is missing, summary need to put it here, petals.lm, then you have to run it. So this is the complete summary of whatever is there inside this formula, whatever happens inside this linear model. So residual values are minimum, 1q median or max, coefficients, estimated standard are t values, and these are the complete details that you can get. And you're also getting the p-value that is significantly less than 0.00, so it is having a good standard value, or it is the results are considerable. And now again, if you have to check the head of iris, again you are getting the same value which we have given earlier. Alright, so this is how you define your models and formula in R. Now there is another thing that I like to share is that if you we are using in this second example, we are using the iris dataset, which is again the collection of information about the sepals and petal and width, petal, sepal length and width, and the species of a flower. Alright, so head we are using we are getting initial 6 values or initial 6 rows from this iris dataset. So now let's suppose if you want to extract few or you want to truncate this dataset into a smaller one. So let's create a different function, df truncate trunk, and then let's put in this the truncated value. So we selected this iris database, and then we will call the starting 100 values. Alright, so let's see what is there in this, if this is okay to run. Yeah, this is okay to run, and if we remove this comma, let's see what happens. Yeah, it is showing some error. Yeah, error in data frame, iris, undefined column selected. So we wanted the initial first value, initial first 100 values or rows with column, all the columns. Alright, so now this is okay, and now let's try to do the summary of this also to see what else will be printed in this if you do the summary, और what all is after truncation इस function में क्या क्या आया है. ठीक है, let's do the summary, and then you can see the sepal length, sepal width, petal length, petal width. So all the 5 columns are there because you haven't given any specific columns, or if you want to give, you can also give the specific column. You have given only the value for your rows. So starting 100 rows you are asking for. So for initial 100 rows, it has given the summary that the minimum value is 4.3, minimum these are the different values for sepal length and sepal width for first 100 rows. It is given the median of first 100 rows for sepal length, so different values. And the species, it is selected Sentosa 50 species. It's initial 100 rows. In initial 100 rows, there are 50 Santosha species and 50 versicolor species, and there is 0 Virginica species. Let's see if you can do same with the column, or you want only the second column. So let's see if this function work. Yes, this is working. So here you can see you are getting the first 100 value of the second column. Or you can put the range here also. Let's suppose we are put here at range first 3. Alright, this is also okay. And then do the summary. So you are getting the summary function of the first 100 rows of the first 3 columns. So sepal length, sepal width, petal length. So this is how you call the different models and formula within the R. I hope you have understood it. And so this marks the end of today's lecture. We are preparing these small lectures just जिससे बच्चों को burden ना हो. 10-15 मिनट में they can give 10-15 minutes on a daily basis, and they can continue to learn the R, which is a very good language when it comes to statistical analysis. So this marks the end of today's lecture, and I'll see you tomorrow.